This is the second last video in the collisions topic, and in this very short video we'll be looking at collisions in a little bit more detail, in particular elastic and inelastic conditions. We define these two types of collisions by what happens to the kinetic energy after the collision. Again, we assume the system is isolated in all cases. So on one extreme there is an elastic collision in which kinetic energy is conserved. So the initial kinetic energy of the system is the same as the final kinetic energy. This is a rare case in most collisions that we will ever observe. So from a ball bouncing on the floor up to a car crash, some kinetic energy is lost. It's transferred to heat or sound. But there are cases where we can say that this loss is so small that we can neglect it, and then we say that the collision is elastic. So for example, if we had a very hard bouncy ball, we could assume that the loss in kinetic energy from the collision with the ground was small enough to be neglected. The second type of collision is an inelastic collision, in which kinetic energy is not conserved. So at some point during the collision, the kinetic energy is converted to a different type of energy. And then there is the other extreme, which is a completely inelastic collision. And this is the type of collision which has the greatest possible loss of kinetic energy, which occurs when the colliding bodies stick together. We know that we're dealing with an isolated system, so in all cases, elastic, inelastic, and completely inelastic, momentum is conserved. We know that the momentum of the system is equal to the mass of the system multiplied by the velocity of the center of mass, and since momentum is conserved, then the initial and final momentum is equal. Since we have an isolated system, the initial and final masses of the system are also equal, and that means then that the initial and final velocities of the center of mass must also be the same. So that is, the velocity of the center of mass of the system is not affected by a collision. And that's really all there is to it for elastic and inelastic collisions. There are a number of interesting cases depending on the speed and relative sizes of the colliding objects, and each of these cases is a question for you below the video.